Hello, in this video we'll be looking at polygonal masonry. Part 2 or part 1 was in regards to the legends in stone softening plants and this particular theory in regard that the stones were somehow softened and put in there together. That link will be in a description. But now we'll be looking a little bit different, a little bit more realised. Now, in regards to the stone softening plant, I believe there's a candidate for the actual origin of the plant, which led to the legend, and it's a myth in regards to the stone softening, but there is a potential candidate for however, there's always a grain of truth in a lot of these stories, and so I believe this is the plant. We'll get to that later, and we'll be looking at masonry techniques and, is there a stone softening plant? We'll come again to this later, but the focus of it will be around this paper on the reddish glittery mud the Inca used for perfecting their stonemasonry by Helmut Tributsch. And so let's go ahead now. For instance, in the abstract, an exception is the reddish mud, Langkak alpa, pardon the pronunciation because I'm not a Quechua speaker, and the gold mentioned by earlier chroniclers as mortar which filled the stones and then later disappeared. As is pointed out in this paper, no gold or silver or similar mortar has been found between the stones, even stones that have been untouched and lifted up in recent times. So, yeah, that doesn't, again, certainly a legend. Also in the paper, he references Spanish chroniclers, including those of mixed Inca-Spanish heritage, who mention the use of conventional tools and the Incan origins of famous sites such as Sacsayhuaman. So, there's a spell over there. I've got it Sacsayhuman, but there's a missing A anyway. This is often the case in regards to sort of alternative lost high technology. There are Spanish chroniclers and legends that the Inca did not build this, and stone softening and these other things. Well, there are Spanish chroniclers who talk about the tools and the quarries and so forth. So that's mentioned in there, but let's just move on. Now, what's he proposing? He's discussing certain aspects, looking at them. He mentions things on the way outside of things, but it's much more grounded. But anyway, so is there a need to invoke chemical treatment of Inca masonry? In spite of a quite convincing reconstruction and experimental verification of Inca stonework, stone masonry technology, Protzen, which places claims of chemical treatments of the fitted stones into the realm of folklore, some open questions remain. So yes, a lot of this is folklore, strategy and guiding hypothesis, knowledge transfer from the mining industry, what chemistry would be needed for leaching and superficially softening the hard Inca stones of mostly volcanic and magmatic origin. In essence, is the Inca were mining. Through the mining process, they would have been familiar with acids and those effects in regards to stone. Almost all of the Inca stone, the polygonal stone especially, is either andesite, which is basalt, or forms of granite such as rhyolite. Natural stone acid etching. So yes, acids can be used to dissolve stone, including granite, quartzite, and marble and limestones, for instance, as well. We'll look at that. So one of the essences that he's proposing is that a red mud was possibly used. Again, I have to emphasise that possibly, because he says a lot of ifs, and so he's talking ideas, not really proposing something solid. A red mud was used which had acid, which helped to fit the stone so precisely. So there is a hypothetically possible. He also mentions old legends which do centre around Jorge Lira and the bird who used a plant to dissolve stone and make nests and these type of things. That was covered earlier. Temporarily softening stone into something like clay or wet cement exists firmly in the realm of legend. There's no evidence for it at all. There's legends, but everything that we know just it's essentially we're talking magic or like super advanced type of technology. So if that's the way you want to go, fine. But there's no evidence for it. It's not even theoretically possible. Okay, so back to superficially or leaching and superficially softening hard stones. There was an acid mud used to create these fine joints between the stones. So let's take a look at a section of wall and the patterns that go on there now. Let's just zoom in a little bit now. Helmut Tributsch, in this method that he's suggesting, not pushing forward, just again more hypothetical than anything, so just again to make that clear. Now for instance, that stone on the top, the red block, you would still need to use traditional masonry techniques to shape the stone to something very close to the fit. Then you would apply this acid mud, and then the small differences would be flattened out. Now, theoretically possible, hypothetically. Now, let's look at a stone. This is from the on top of the hill above Sacsayhuaman. So you have roughly tooled surface. Now, if there's high spots, low spots, high spots, low spots. Now, for instance, so you'll take the roughly dressed stones, you'll place them, put them in contact with this acidic mud applied between, and what you should have is a bunch of flat spots. So where the two high spots are meeting, the most pressure, the most contact. Well, what we don't see that, or I haven't seen that in any stones. This should be quite common. Now there might be one or two stones that I haven't seen that have been dismantled, and we can see that might have that. Well, okay, mate, that's a possibility there. I haven't seen them. I don't think they exist. Again, they might be. I just haven't been exposed to it. But what we of all those that are available, we don't see it. Now there'd be another feature that goes with the use of acid, and so even mild acids, citrus juice, wine, coffee, will etch or stain even granite countertops, and especially with marble or limestone, even more so. Again, I just haven't seen any staining on these stones. I'm not an expert on there, so maybe I'm missing signals that should be there. But again, from what I've seen, the telltale signs of what should be this using acid process just doesn't seem to exist. There's a video, natural stone acid etching. I'll put that link in the description. But so to simulate what would happen if you were to like cut a lemon in half and put it on top of a stone and leave it there for 48 hours, he uses a stronger acid. So first he does it with limestones, marbles, and you notice that the chemical turns white. There's a strong reaction going on. So it's just like putting limestone in acid. You see the carbon dioxide bubbles come out, so the calcium carbonate, the reaction, and it leaves a stain, an etching, so like a little scoop, tiny little scoop mark, very shallow. Now he does the same with basalts and granites as well. Now notice that they don't change colour. Now they are having an effect on the stone, but it's nowhere near close to stones such as marble, made of tiny little shells, as opposed to the volcanic magmatic stones. And this piece here is basalt, and because basalt is much more porous, the acid it goes into the little pores, and so this would also apply to this acid etching method. If you put the acid in there, it's going to absorb into especially the andesite, and the reaction would keep on going. So this is a problem, I believe, that exists with this particular method. So like with the red block, nice and easy, I'll put it on top with the mud applied in between, yes, okay. But what about fitting it into a place like this where you have to insert it into there? Well, that's going to be a problem, because firstly, again, the block would still need to be conventionally shaped to something very close to the final fit. but you would also have to leave a little bit of extra meat on there. So it's basically you'd have to make exactly this type of stone that you want to fit into that gap, but by design have just enough left over, a little bit extra for the acid to eat away at the stone, and eat away at exactly the right amount, because the acid's going to eat in all directions. So even the stone that you're fitting it to underneath, you would have to leave a little bit on there, and we're talking a very small amount, so it would be very hard to judge that. So when you're trying to slip a stone into any of, well, you'd have to make it bigger. Now that's a big problem. Now, of course, also the acid will be neutralized by the stone it's reacting with, so that acidic mud would have to constantly be reapplied. It's barely an improvement on the conventional method, only more potential problems, things to go wrong, including skin, logistical issues of getting all that acid there and storing it, applying the acid in just the right way so that on the left hand side is getting the same as the right hand side, shaping the stone so there's just enough extra meat to fit into that gap. Then we'll have the stone that you're fitting into, the underside, you'd have to have that smaller than your final design, because some of the acid has to be eat away at the stone there as well. So there are a lot of problems going on there. It's more problematic than just the traditional method, which is still relying on to get those stones close to the shape. And again, you have to design the stone to be just that little bit bigger or just that little bit smaller underneath to make that, because the acid is going to be eating away. Now, for instance, if I was to try and insert this blue block into the, well, I would have to make, the green block, I would have to make it larger than the place I'm inserting into, because the acid's going to be eating away. Now, as I'm trying to get it in there, the acid would wear away and create a tapering, and then it's a little bit exaggerated, but you're going to have larger gaps in there. You could sort of overcome this by designing the receptacle of where it's going to be put in, and then have that in a certain form, and then have the block designed in a particular way with just the right amount to slot in there. But again, it's just adding a whole new layer of difficulty to the job. And in the end, you're still going to be relying on masons to be super skilled in their shaping of a stone, then adding the calculations of, well, how much is the acid going to take away? And it's just like adding problems that don't really help you, just adding issues. So it's not impossible, but it's more problematic than the traditional method. Okay, so here's wall sections 26 and 27. This is a diagram from Protzen's paper, and there's an old photo. So again, we can see the condition of what it was like in the past, and it's this area especially, because that's wall sections 26, 27. So again, you can see where that large stone on top of a smaller one, and that there, and then again you can just compare how it used to be to how the place looks now, including this hill here in the background and the amount of earth that's been removed from the top there. But anyway, the point is this stone. So looking at that method, the blue stone there, that would be the keystone. So you could sort of insert it in there and just to get the fine fit, use this acid method, but that's also, it's acting as a keystone. So it's also about how were these structures put together. Well, they'll put together in a certain order because they need to be taken apart in a certain order. Now, for instance, I take out that keystone. Now I can remove all those stones because the keystone was locking them in. Find the next one, you remove that, and you can go down and then follow it through. And I want to come back to this because then we have these large stones. So the basic concept would be, we'll start at the corner with the really large blocks, and then where have we gone from? And then build up. Okay, we'll come back to this later on, but back to these stones. Now, pick the most difficult one, for instance. Okay, there we have on this particular area that has the most corners and curves, and then consider how the stones are brought together, and we look at the stones that we can see the sides of them. Alright, so focus on that one. Now what's happening with these, and this is still a method used today by traditional masons, is not to have too flat surface. So a lot of people look at, for instance, Hindu temples and they're just blocks, but there's more going on there. They have subtle curves and stuff in there, and they still use this method of having cup and saucer, so the underneath stone is concaved, so it receives the one at the top. On the outside it looks much nicer, but from the back, yeah, it's quite rough. And so just that zigzag, we'll look at examples of that in a moment. But usually, not always, but the bottom is fit very well, but the side joints, only a small part, only that nearest the front, is actually fit very, very tightly. Okay, so as an example, this is what those giant walls look like from behind. So just as, you know, so these are not cast, these are not formworked, these are just stones that have been fitted together, and you see, because this would be covered from behind, you don't need to make them look beautiful, and there are, well, big gaps between. They're not fitted tightly. From the front you see those stones and it's got that, it look like these, but from the back it looks very different. Here's another example we can see from the back. From the front, again, that beautiful polygonal work. From the back, well, rough stone, and including, you know, sort of large gaps in there. This is tambo mache, you know, hot. So this is one example you see where even the top and the bottom are not perfectly fit. Only the front face is, and then the back of the stone is filled in with rubble to support it. I'll try to remember to put the link in the description where Japanese masons dismantled one of these giant walls, put it back together. This is a method that they use. It's dry stone wall method, very common all around the world. Outside, beautiful. Once you go behind, well, not so much. Alante tambo, we can see the same thing. When you see from behind the stones, you know, on the outside, oh, this is cast, it's cement. Well, no, it's not formworked in cement, because again we see it's rough stone from the outside. If this was poured or cast, it would act like a liquid. There'd be no gaps anywhere, but they're all over the place once you look at the little details. Also at Alante tambo, again you can see from the front looks beautiful, and it is beautiful, but when you look at the back, would you paint and polish the back of your wardrobe? No, because it's just the bits that you see is what you focus on. Machu Picchu has the same thing. There's been a bit of like earthquake and subsidence, so these stones have moved apart, and we can see again from the rear what's going on. Rubble infill. In Machu Picchu there are freestanding walls, so this would be a retaining wall. There are freestanding walls where the front and the back is beautiful, because you can see both the front and the back. But most of this Inca stonework is retaining walls, and so from behind they don't need to be beautiful, they just need to work. So now we see the shape of this stone, and we also consider the side shape. So if I was to take this block and cut it along its height or across the horizontal, it's essentially going to be it's like a uniform shape. It's predictable what you're going to get. Now consider this. Okay, here's a broken stone, shattered stone. So if I was to cut along one axis, I'm going to get a squiggly line like this. Then I cut across at 90 degrees, it's going to be different, another type of squiggly line. Now if I was to rotate 15 degrees or 30 degrees, that shape is going to completely change. If I'm looking down on it and I trace out a shape at a certain height, it's going to be a squiggly circle, a half circle like that. If I was to go up a little bit, the shape again would totally change. This represents utter chaos in 3 dimensions, as where this is complex but predictable. It's not, it's easy to visualize the shape. This is chaos, there's some order, this is ordered, this is pure chaos. So if this polygonal stone walls in Peru are 9.5 out of difficulty, then this is 950 out of 10 in difficulty. I've had some discussions, people like saying that the polygon, no, I'm sorry, look, the geometry of this shattered wall is so much more complex compared to this one that they're in separate universes of complexity. So if someone can fit stone using traditional techniques to a shattered face, then doing something like this is child's play in comparison. So how would they do it? Would they use a secret stonemason's stone softening plant and an acidic red mud to fit these stones together? Well, sort of, but yes, but no. To the uninitiated, stonework's always been a bit of, it's one of those mysterious, like amongst all the old traditional crafts, it's the one that sort of invokes the most mystery. Now I'm going to tell you that they're using a stone softening plant, and now they're going to use this tool, and they're going to turn that octagonal piece into a column drum. They've softened the stone, and then they drag this around, and it cuts the stone. That's how they made the column drums, using this stone softening plant. Well, that's not the case, okay, now, but you could see people would believe that. Now, here they're going to fit this stone to the shattered block, so brand new stone, going to attach it to this shattered old stone, and they're going to use an acidic red mud to make that fit. Again, you could see how this would be interpreted for that way. Now, Barry is applying the now he's going to apply some of his mud, acidic mud, to do this perfect, beautiful fit as well. And again, V shapes in 3 dimensions, just so much more complex than those Peruvian walls. So look how they do that fit there, perfect. Did they use stone softening? Did they use an acidic red mud? Well, no, they didn't. So back to this Protzen. And contemporary quarrymen, speaking about people in Peru, dig up the root of ubiquitous bush named lawley, which has a deep yellow sap, and use this root for marking in the manufacture of paving tiles. So Peruvian, the ancestors of the descendants of the Inca, use this particular plant to mark their stone. None too different than what these people are actually doing. So these are Greek guys. They had a huge budget for this Parthenon reconstruction. Instead of using expensive engineering dyes, the traditional masons chose to use these plants to mark the stone. It's not stone softening, they use it for marking. And the people in Peru have a very similar plant, the lawley. Now, lawley, or the Bonadesia horrida, well, this is the plant that again grows all over the joint, all that around that part of the world. There's its range, high altitudes, lower altitudes, grows into quite a big bush. Thorny, used also as a medicinal plant, and also because of the thorns, they use it to protect the fences. So planted along the fences, all those thorns stop the livestock from knocking them over. Machu Picchu, Ollantaytambo, Sacsayhuaman, but now north of Ollantaytambo we have Lawleyok, which again translates to one with the lawley. But this plant's it's an important traditional things going on there. Now Sacsayhuaman is another smaller site up here. Carretera, Lollipata, has that same named up. There are a few other places there named up now, just because there's no places named after it. I'm just trying to point out the significance that it's an important plant. There's we've got a nice stone wall there, and also this carving. We'll come back to that in the next part when I look at vitrification. Alright, so this plant was being used, and probably still is, so very recently, by masons to mark out paving tiles. And I would very strongly, I'd be very, very sure that they didn't just pick this up in the early 1900s, that this is probably a tradition which goes back to before the arrival of the Spanish. So how traditional masons fit incredible shattered stone together again, just way more complex than the I'll put the link to the larger compilation in there. It's not just 1 or 2 blocks, and it's not just a method that has just reappeared recently. You'll see in a lot of these old rebuilds, reconstructions, that this particular, we can see shattered stones put together. So they get the rough shape, then they apply this red mud, they get it to touch, whether where it touches, it's going to leave a mark on the mud. Or that means it's a high spot. You take that away, then you test it again, find another high spot until eventually you get a perfect fit on a shape that's just leagues more. So you can see little white dots there. Yeah, now take those spots, remove it, paint it over again with the mud, test it again, and this is how they made these stones fit perfectly. Again, orders of magnitude more difficult compared to those polygonal walls. Using the mud, which have been traces of dirt, basically, dried mud in between the stones, and also the lawley. So I think that this lawley plant was the origin of the stone softening. People see the masons chose this or possibly another plant, but I think this one would be a good candidate. They saw it rubbing it on there, and look at this as the magic plant, and I would play this. I think a lot of tradesmen know what I'm talking about when the noobs come in, and it's like this is a magic. Look, it's going to soften the stone. This is our secret. Don't tell anyone. And then the legend builds over time. Now, they're still using it to manufacture paving tiles. Now, there are paving tiles which are out on the street, which use like grout, mortar in between them. But you also find, beautifully fit paving tiles as well. So again, this is how to mark, fit stones. This is a method. I'll link those papers in the description. So now this is wall section, is it 16 or 18? But anyway, all right. So firstly, you see the big stones. Well, how did they, move them back and forth and get them to fit using that particular method? Well, first thing would be is not to move the big stones, but to place them down. Start at the corner, put your big stone in between on the middle of the wall, and then fit the smaller ones to it. That would be the first and obvious step. Big stones such as that Sacsayhuaman are the rare exception rather than the rule. So, but how would you do it? 1,000 times. Well, you don't have to, because most of these types of walls are small, man-handleable stones. You wouldn't even need levers or that. Just a couple of guys lifting them up. So there's like a handful of really large stones exceptions, but the rule is smaller stones such as these. One of the exceptions would be the 6 monoliths at Alante Tambo. But even those are not fitted together. So I've just marked them out. But we have a shim, 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 shim. So you get them close and you insert these pieces. So again, these are small, light stones that, again, a man could, a couple of guys just with, a lever, one guy and a lever could move. So you only need to fit those type of stones in there together. And because you could also insert them from behind, you don't necessarily have to drop them in from the top, but given them the shape that they have, they seem to be like where you could slide them in from the top. Anyway, okay, so when they show this one, well, how did they perfectly fit the stones? They didn't. They perfectly fit the little shims in between them. All right, now, but it was quarried. How did they move them 35 miles away? Now, in the larger Sacsayhuaman site, they do use andesite, which comes from 35 kilometres away, which is up the valley. So it's, how did they bring them up the sides of mountains? Well, it's the Rocky Cola quarry, 35 k's away, so the stones are brought downhill, down along the valley path. These large stones all come from this area right around Sacsayhuaman, 2 kilometres, 1.3 miles away being the furthest point, and that's downhill to get the stones there. So they didn't come from huge distance away. They weren't brought up the sides of mountains. They were brought close by, downhill. Here we see a photo up towards that area, and there we see the sawtooth walls, the big stone walls there. So downhill, it's not very far away to move at all. How would you fit the stones together? Well, the first step would be I got some clips. I try to post them on YouTube as a compilation, but they got blocked worldwide. I can't show you them. One of the ones was Blowing Up History of a Machu Picchu edition, and they show stones halfway incomplete. So, stones that are half processed, and you can see the method of how they were working to do that. I wish I could show you those. Vince Lee is one of the fellas to look up. All right, but with very simple scribe tools. So, like a fork stick with a plumb line, the plumb line ensures that the stick stays horizontal. Then you can measure the distance between the stones, and when the stick doesn't fit because it hits a high spot, well, there you mark it, you knock that down, and then you keep doing it until you can get them to fit together. The sides of the stones, only the front part is connected. They're not all perfectly precision, touching each other to nanomillimeter perfection. That's just on the face of things. Scribe tools, there is a bit more modern versions, but it's a very simple concept. You measure the distance, you set the scribe tool, you run it along. When it fits, okay. If it's wobbling, it means, well, it's too big, we're going to have to reset, so that's not a good thing. If it doesn't fit, well, we need to remove a bit of meat and until it all goes along smoothly. It's not a very complicated process. It is a patient process. You have to be careful. If you make a mistake, well, you sort of have to not quite start over, but reset everything at least. So this is wall section 18, so I'll go back to that piece I showed you before. So wall section 26. It seems to be from the images I've got. So you begin at the corner, and you would have to get these 4 stones to fit together. So they're still quite large. Well, one of the steps would be lay them down on the ground and use a scribe tool such as this to get them very close, and then to reduce the amount of time you would need to do that fit testing of them. And always again begin at the corner with the large one, and then get the other ones to fit according to that, and work your way across. All right. I'll link this paper, Fabrication Methods, Polygonal Masonry of Large Tightly Fitted Stone Blocks with Curved Surface Interfaces and Megalithic Structures, Peru. That rolls off the tongue. He goes through all interesting paper, and he talks about things such as this translator or pantograph, still used today. Now, for instance, I'll link this as well, where a guy makes a beautiful sculpture and he transfers the clay model into a stone model using a pantograph. Again, precision, just making a sculpture such as this from a replicating it, again, just makes the stone walls look rather simple in comparison. And I'll also link this, how to make a giant symmetrical Egyptian statue without ancient high technology CNC machines, where they use a very similar method to make giant statues, basically plumb lines and rulers, transferring very much like a scribe tool, using very primitive tools. You can do this. The Protzen's paper, he also did some testing. People say, well, I want to see a giant wall made. Well, you don't have to, because you can, well, actually, because they have made even better. I'll try to remember the link in the description. Granite lighthouses of the UK. The polygonal masonry they did with granite before advanced technical machinery, hand tools, the complex polygonal 3-dimensional lighthouses that they made, again, just make the Peruvian retaining walls look rather simple. Pardon? I'll try to remember to link that in the description. So if you say, well, I want to see it done, I'm just going to tell you, well, you want to see even better done, go look at these places. And just like that clip I showed before, the Parthenon restoration, well, you want to see it done, these guys are doing it here. If you say, well, I want to see a Peruvian replica wall, well, you go and learn the skills off those people, you fund it and you do it yourself, because if you have to see this to say it's possible, I can't help you. You don't understand how things work. No one's going to do this work for you, because you're not worthy of the effort to put into it to show to you. So anyway, now we have a common, the so-called nubs or bosses, these protrusions that we've gone forward. We also have these indents. So here's some of the screenshots. I forget this fella's name. He's specialises at Machu Picchu, and he visits a few other nearby sites where you see half-processed stones halfway through the fitting process, and very similar to this image where they're propped up, they start the smoothing process, and sort of there you can see the nook, and this stone here is holding this larger one up, and this nook is going to fit into this position here. There's also stone rollers in examples such as this, so they can move the stones backwards and forwards and start scribing them down, fitting them together. So there are half finished stones where we can see the work again that's in those documentaries. I wish I could show you those clips, but again, blocked worldwide whenever I try to post them. Question of lifting. The blocks never need to be lifted by a giant crane. When people think about moving big things, they just instantly go to a giant crane and they're going to deadlift it up. You don't need to do this, and this you'd only lift with a crane like this unless you really have to, because it's a dangerous, risky thing. How would you do it? Well, here's a video of some bored German teenagers. There's a big block on top of a bank. They just undercut, dig underneath it, undermine it, lever it from behind, and they send it over the side. This would be one of the ways you could do it at Sacsayhuaman. So those giant stones, you bring it in from behind, essentially because the wall, it's earthen wall behind. Get it close to where you want to. Dig underneath one side, it's going to tip forward. You place your stone that way. Again, can be done. I'll link videos in the description in regards to lifting and moving of large stones and people using primitive tech to do it. Alright, so another way would be to come from the front. So if you use this method, you would have the back of the stone on the ground. If you're coming from the front, you would have the front of the stone on the ground. Build a little earthen ramp, bring it up, dig away. It's going to tilt over. Now, because it's one corner is touching, it's already tilted, you don't need to lift anywhere near the whole weight of the stone to bring the rest back up to vertical. But if build a height, so that last ramp I built was about illustrated, alright, not built. Build one that's about 10 feet high. It's just moving some soil, undercut, and then you can get it nearly to vertical, or even to vertical as well. To stop it tipping over, you could place a weight on the end, or just tie some ropes down, and it's like a seesaw, and you get it in. If you want to see an example of Wally Wallington on his own moves a 20-ton stone and just uses a seesaw, so he's doing even more difficult. He's like lifting it and then tilting it, not even ramping. Primitive methods, a little bit of logic and experience. Absolutely, these things can be moved. I'll link these in the description as well. Absolutely, they can be moved with primitive, very simple technology, and not only moved, moved into, elevated into place, and moved with very high precision as well. Because if you set up your rails right, the thing steers itself. All right, those links will be in the description. Sumba as well, there's still a megalithic tradition with vine ropes, the same how to do primitives with vine ropes. Well, because they're still, anyway. Alright, so back to this. On the reddish glittery mud the Inca used for perfecting their stone masonry, or one of the points possibilities he brings up, the acid to fit the stone perfectly, hypothetically possible, though it has its problems. Especially that you would still have to rely on conventional techniques to get the stone to the shape, and you would have to shape them, have a little bit more meat on them so that the acid's got something to chew away at. Then you would have to control and stop the acid before it over dissolves away the stone. So yes, hypothetically possible, but there's a lot of extra practical problems, and it still relies on traditional masonry techniques and them being very accurate. So yes, it could have been, but there's no, like the staining, flat spots that you should see on stones that have been taken away. That just doesn't seem to be a thing, and so I don't believe that it was done, and not necessary. And we saw examples where, and again, links in it, where masons can do better work than those Peruvian walls with hand tools. I'll also link in the description, but the copper tools, I've done some videos on that as well and showed that as well. So if it's like, well, oh, but they had steel versus copper, look, no, stone tools is just as good as a steel tool. It's the skill of the worker. You know, steel doesn't transfer magical precision abilities. Flint tools, hematite, they work just as well. It's the skill of a mason, not the material. Next part will be about vitrification. Got a bit to say on that. And this is another one of these sort of things that goes around. That'll be for the next video, but fitting the stones, yeah, could be done without acid, but I don't believe it was. No real evidence sort of for it. And in regards to that stone softening plant, I believe it was Valauli, because it's still being used now to do the marking. And as we saw with those examples, yeah, traditional methods work really well. And for this type of very skillful, you know, where fitting a shattered stone, you really need skilled traditional people to do it. And again, also, if I was to say, well, they're stone softening, they're using their secret stone softening plant, look at them, this is how they carve out, you know, they're just going to go around and make a column drum with this way. You could, yeah, I could see people who are going for that, or they're using an acid mud to fit this together. Yeah, you know, you can't blame them, because they, you know, it is a bit mysterious stonework. It always sort of has been. All right, with that, links again in the description, and more to come on the vitrification and, well, so-called vitrification. We'll look at that and the sources and that type of thing. Spoiler alert: it's not looking, you know, not looking good. All right. With that, yeah, you know, and please, if you're going to comment, and I'll put the links in the description, which already answer these comments. That's why I sort of want to make these videos. Yeah, all right. I won't rant on that, but if you're going to, links in the description, watch the video. Yeah, with that, SGD, cheers, and have a good one.